And our final lesson in Unit 3 is on writing systems of inequalities, and that is our goal for section 3.6. So please read through the first example here and see if you can come up with the system of inequalities. And for this example, one of our inequalities should have been 10x plus 15y, because we're talking about $10 per hour walking, and walking would be our x, and then 15 per hour tutoring. So 15 is going to go with y. And then from there, since these are both talking about money, I want that to have a relationship with the $95. And since it says that he must earn no less than $95, he needs to earn at least $95, which means greater than or equal to 95. Now from here, there's only one other number that is listed, and that is this 8 right here. And it says he has to work a maximum of 8 total hours. So when we're looking at that 8, you want to think, is that dealing with our variable for x, y, or both? And in this case, that's 8 total hours, and that is going to be between the 2 jobs. So we don't need to talk about how much he makes for each job. We just need to talk about the number of hours. So that is going to give me x plus y. And I know that the 8 is associated with that. And because he has to work a maximum of 8, that's why it's going to be less than or equal to the 8 hours. Now in this part, we're looking at the exact same example. So we already have the 2 systems that go along with this example. What we want to do is actually graph this now. So in order to do that, we might want to solve both of these for y and then be able to graph them. You could also do it with x and y intercepts. So take a minute to come up with those 2 inequalities solved for y. Now in the top one, if I start by subtracting 10x over, dividing everything through by 15, I'm going to come up with y is greater than or equal to negative 2/3 x plus 6. So we can go ahead and graph that in a minute. For our other one, I'm subtracting the x over, and I just get y is less than or equal to negative x plus 8. Now as we go to graph it, the blue one is going to start at positive 6, and it has a slope that goes down 2 and to the right 3. So I'm going to go ahead and continue that through and form that line. Then for my bottom one, I can go ahead and plot a point at 8. And then this one also has a negative slope. It goes down 1 and over 1. Here I've shown that it goes down 2 and over 2 because that is the exact same thing as going down 1 and over 1. And that forms this line. You'll notice that they're both considered solid lines because of the equal sign being in here. And now what we want to do is think about where we're going to have to place our x. What part, which region here out of the 4 different options is going to work for both. Now when I'm looking at the blue line, that is greater than. So because it's greater than this blue line, it would be in this region or it can be in this big space over here. But for the purple one, it ends up being below that line. So below this line is either going to put me in this region or it's going to put me in this region down here. So therefore, the overlapping region ended up being this section right in here. Now, really, I shouldn't be going into the values where x is negative because you can't work a negative amount of hours. So it's really just going to be this little like triangular area right here. Now, in this next part, we can get multiple different answers. So what I'm looking at here is anything that falls in this region is going to be an answer. So come up with an example that would work for this problem. And what I'm coming up with is 1 hour walking. So I would go over 1 here. And then I could pick, this might be around 5.5. I could even pick 1,6, or I could even pick 1,7. And I chose 1,7. That's going to maximize how much money he would make. Then from there, you could put a lot of different options. Here are a few things that would have worked. He could have walked dogs for 0 hours and then tutored for 8 hours. That would work. He could have walked dogs for 2 hours and then maybe tutored for 6 hours, or even 3,5 would work. But there are many different options that would work for this one. Now you have an assignment in Delta Math that you'll complete for homework.